Ever find yourself like, wow, I saved a bunch with that. Buy one, get one, 50% off deal. Or maybe just amazed by how your phone knows the fastest way home, even with like crazy traffic.
Yeah, it is pretty wild.
These like everyday things, they seem so simple, but there's actually some serious math power going on behind the scenes.
It really is everywhere when you stop and think about it.
Welcome to the Deep Dive, where we break down fascinating topics and make them clear and fun for you. Today, we're going deep on why mathematics is so incredibly important.
Super important, absolutely.
And for this deep dive, we're using this document you shared, The Importance of Mathematics and Why We Learn It in Mathematical Terms and Language. We want to show you just how fundamental and relevant math is to your life, no matter what you do. Like, you don't have to be a rocket scientist to appreciate this stuff.
Nope, not at all. This document does a fantastic job of showing how math is this universal language and how it impacts our lives in practical ways every single day. From the tech we use to the choices we make, it's all connected.
I was blown away by that concept, actually. Math as a universal language. It's mind-boggling when you really think about it.
Right, it's like math doesn't care about your culture or the specific language you speak. It's just true. The core principles are the same no matter where you are on the planet. It's a way of understanding the universe that everyone can share.
Yeah, exactly. And the document gives this really clear example with the Pythagorean theorem. That thing about the sides of a right-angled triangle, a squared plus b squared equals c squared.
Classic.
That holds true whether you're in like Italy or Argentina or anywhere. It's not just a theory, it's this fundamental truth expressed in mathematical language.
And that's what's so powerful about it.
Absolutely. So, if we zoom out a bit and look at the big picture, you can see why this universality is so important for progress, right? Scientists and researchers all over the world can work together, share their ideas, build on each other's discoveries because they're all speaking the same mathematical language.
I mean, imagine if every scientific principle had to be constantly translated and interpreted differently. Talk about a roadblock to progress.
Total chaos. Yeah, so math acts like this, like invisible but incredibly strong thread connecting all these great minds and innovators around the globe. Is pretty amazing.
It really is.
So let's shift gears a little. We've been talking big picture, universal stuff, but let's bring it down to earth and get a little personal. How does math shape our everyday lives, even when we don't realize it?
This is where it gets really fun, I think.
Yeah.
Because the document does such a good job of showing how math is woven into our daily routines. Like, think about managing your money, budgeting, understanding interest on a loan, figuring out if that sale price is really a good deal or if they're trying to trick you.
Yeah, you got to be savvy.
It's all math.
It totally is. And it's not just about money either. Think about cooking. Recipes are basically mathematical formulas, right? Ratios of ingredients, precise measurements. Even arranging furniture in a room uses geometry, that branch of math that deals with shapes and space. You might not be pulling out a protractor and measuring angles, but you're definitely using spatial reasoning, which is rooted in geometry.
Yeah, that intuitive sense of how things fit together. It's math in action.
It totally is. And planning a trip. Oh man, you're using math constantly there. Calculating how long it'll take to drive a certain distance, figuring out time differences, even wrapping your head around the chances of delays.
Yep, probability. Another area of math.
Right. And we use that in everyday decision making all the time, right? Weighing potential outcomes and making the best choice. We don't always write down the equation, but we're doing the math in our heads.
For sure.
It's kind of mind-blowing when you actually list out all these examples, how many of our daily activities rely on these underlying mathematical principles.
Right. It's everywhere.
It makes you wonder if we can navigate our lives even better if we were just more aware of the math at play.
It's an interesting thought. I mean, it's definitely worth considering, right? Take a second. Think about your own day. All the decisions you make, the tasks you do. How many of those actually involve math, even if you're not consciously thinking about it?
Yeah, that's a good challenge for our listeners. Now let's talk about an area where math is like front and center.
Yeah.
Science and technology.
Oh, absolutely. The document makes it super clear that math is the foundation of all the scientific disciplines. It's the language they use to describe, explain, and predict how the world works.
So can you give us some specific examples, like how different scientists use math?
Oh, for sure. In physics, the fundamental laws that govern how the universe behaves, they're all expressed as mathematical equations, like Newton's laws of motion or Einstein's theory of relativity. They're all written in the language of math.
Right. I remember those equations from school.
And in chemistry, mathematical models help us understand how molecules interact, how chemical reactions happen. And even in biology, we use math all the time. Like understanding genetic inheritance involves probability and statistics. It's everywhere.
So it's not just about like planets and stars, it's about life itself.
Absolutely.
And then when we look at engineering and computer science, I mean, math is just essential there.
Oh, completely.
We're talking about calculus, which deals with like rates of change and accumulation. That's crucial for designing things like bridges and skyscrapers that can withstand all kinds of crazy forces.
You've got to make sure they don't fall down.
And then algebra provides the framework for writing computer code, and statistics, that's like the backbone of developing algorithms that power things like, you know, internet searches or AI.
Yeah, all that stuff we rely on every day.
It's wild. So math isn't just this abstract subject, it's this incredibly versatile toolkit that drives innovation in so many different fields.
Every single technological advancement you see, it all has a mathematical basis.
Wow. So it really shifts your perspective, you know? Math goes from this thing you might have dreaded in school to this essential ingredient in all the progress we've made as humans.
Definitely.
Now, let's switch gears again and talk about a benefit of studying math that goes beyond just like specific applications. How it trains your brain to think logically.
Absolutely. The document talks about how learning math helps you develop the skill of logical thinking and problem solving. And it's so true. Math teaches you how to break down complex problems into smaller steps, then work through those steps in a systematic way to find a solution.
It's like a workout for your brain. It teaches you to be organized and focused, to think step by step.
Exactly. It's about having a strategy.
And the best part is these logical thinking skills, they aren't just useful for math problems. You can use them in pretty much any situation in life that requires you to think things through carefully and make decisions.
Right. From dealing with a problem at work to figuring out a personal dilemma.
Exactly. And you know, math also helps you learn to follow a logical argument, spot flaws in reasoning, think critically, all super valuable skills no matter what you do in life.
Totally. And that brings up a question for you, the listener. How could you use these mathematical problem-solving strategies to improve your own life, both professionally and personally? It's something to think about.
It is, for sure. Now, let's get into something that might sound a little intimidating, but it's actually quite beautiful, the language of mathematics itself.
I love this part because math has its own precise language, complete with symbols and notation.
Yeah, like a secret code.
Kind of, but it's really elegant.
Yeah.
And the document stresses how important this precision is for communicating clearly and accurately. It's different from everyday language, which can sometimes be open to interpretation.
Right, like someone might say a lot, but what does that even mean?
Exactly. But in math, a lot has to be defined. Maybe it's 100, maybe it's 1,000, who knows, but it has to be specific.
So everyone's on the same page.
Right. And this precision is so powerful. The document uses Einstein's famous equation, E equals mc squared, as an example. Just a few symbols, but they convey this incredibly profound relationship between energy and mass.
That's like the most famous equation ever.
Right. And imagine trying to explain that same concept using only words. It would be so much more complicated and confusing.
Yeah, and probably a lot longer.
Definitely. And the document makes a great point about how this standardized language makes communication so much easier across different fields and across the globe.
It's like a universal translator for complex ideas.
Exactly. A scientist in Japan and another in the US can both look at the same mathematical expression and instantly understand it. No translation needed.
That's amazing.
It's super important, especially in fields where getting the details right is critical for making progress.
Totally makes sense. All right, let's bring this into the 21st century now and talk about the role math plays in the digital age. You know, all the technology we use every single day.
This is where you really see how those seemingly abstract mathematical ideas have a very real impact on our world. The document specifically talks about cryptography, which is the basis for secure online transactions and communications. Keeping your online banking and messages safe from prying eyes.
Yeah, super important these days.
It's all thanks to math.
Whoa, never knew that.
It's all built on mathematical principles, like super complex codes and stuff.
That's so cool.
And then there's machine learning and AI. Those are rapidly changing so many aspects of our lives. And guess what? They rely heavily on statistics, probability, and something called linear algebra. These mathematical frameworks allow computers to learn from data, make predictions, and do increasingly complex tasks.
So those things we hear about all the time, like self-driving cars and stuff, it's all math.
Pretty much. And then think about data analysis. It's used everywhere, from business to healthcare. And it relies heavily on mathematical modeling. These models help us make sense of huge amounts of data, identify trends, and make smart decisions.
So like figuring out the best marketing strategies or developing new medical treatments.
Exactly. Math is the engine driving all of that.
It's really eye-opening to realize how much of the technology we depend on every day, from online shopping to personalized recommendations to medical breakthroughs, it's all built on this foundation of mathematical understanding.
Absolutely. It's all connected.
Now, the title of the document we're discussing specifically talks about learning mathematics in mathematical terms and language. Why is that so important?
It's a great question, and the document gives several reasons why learning math this way is so crucial. First and foremost, it's about precision and accuracy. Mathematical terms like limit in calculus or derivative have very specific and unambiguous definitions.
So there's no room for misinterpretation.
Exactly. This avoids the confusion that can happen when you use more general language. It's all about having a shared and exact understanding of the fundamental ideas.
That makes total sense. What's another reason?
Efficiency. Mathematical notation is like shorthand for complex ideas. The document gives the example of a probability equation. If you wrote that out in words, it would be super long and complicated. But using mathematical symbols, it becomes much shorter and easier to work with.
So it's not just about being precise, it's also about being efficient.
Exactly. You can convey complicated ideas in a clear and concise way. And remember that idea of universality we talked about earlier?
Yeah, math being a global language.
Well, learning math in its own terms reinforces that. Because math is a global field, having a standardized language of terms and symbols allows students and professionals from all over the world to collaborate and understand each other's work.
Right, it breaks down barriers.
It does. When everyone understands the same mathematical vocabulary, it creates a much smoother exchange of knowledge and ideas.
It's like having a common ground for innovation.
Exactly. And another important reason the document highlights is the ability to use powerful problem-solving techniques.
So it's not just about understanding the concepts, it's about being able to apply them.
Right. When you understand the language of math, you gain access to a whole set of specialized methods, like algebraic manipulation and calculus. These techniques wouldn't be possible if we were limited to describing everything in everyday language. It's like having the right tools for a specific job.
I like that analogy.
And finally, the document mentions how learning math in its own terms helps connect different fields of study. So many diverse fields, from physics and economics to computer science and even some areas of sociology, they all rely on a deep understanding of mathematical concepts.
So it's like math is the key that unlocks all these different doors.
Exactly. It prepares you to think across disciplines and see the connections between seemingly different fields, which is where a lot of exciting innovations happen.
It's like being a polyglot, but for knowledge.
I love that. It's a great way to think about it.
So, to sum up, we've explored math as this amazing universal language that's like the bedrock of our world, from scientific discoveries to everyday life. We've seen how it sharpens our minds, gives us this precise and efficient way to communicate complex ideas, and powers the technology that shapes our modern world.
And we've learned that learning math in its own specific language unlocks a deeper level of understanding and gives you powerful problem-solving tools.
It's been quite a journey.
It has.
And we hope this deep dive has given you a new appreciation for math and its incredible impact on your life, no matter what you do or what your interests are.
Absolutely. It's all around you.
So as you go about your day, consider this. How many future innovations, things we can't even imagine yet, will be built on this foundation of mathematical understanding? How might math help us solve some of the biggest challenges we face, like climate change or finding cures for diseases?
It's an exciting thought.
It really is. Thanks for taking this deep dive with us.
It was my pleasure. Always fun to talk math.